So, welcome to the week number 2 of our NPTEL course, Scientific Computing using Python. So, before we start, in case if anyone missed last time, this is how the sessions occur every Tuesday, 6 to 8 p.m. And we'll meet for 12 weeks. This is the second week. And it's going to be very interactive and informal. Language will be English, and you can ask questions anytime. Please do not hesitate. Okay. And the common drill is to first do recap of what was done in the week, then we do some coding, and at the end solve the assignments from previous year's question. Okay, so before we start this week's session, by the way, this is where you find all these recorded lectures, I mean the recorded sessions of these tutorials, and this Google Drive folder is where all these slides will be uploaded. Okay, and the codes. And if you have any queries or anything, just shoot an email to me. All right. So what we saw last week was first what the course is about. It's about scientific computing, and the tool that we are using is Python. So we are spending few weeks on Python, and slowly we'll start learning how to do computation, etc. Uh, and why we need computers. I think it was made very clear. There are problems that cannot be solved using pen and paper, and now that we have computers, we must use them. Okay, we talked about memory, how computer takes data, what is a byte, kilobyte, etc. Right? How numbers are stored. For example, for double float, you have 8 bytes, and there is an ingenious way in which you can store those numbers in the range 10 to the power minus 308 to 10 to the power 300. So indeed a vast range using only 8 bytes. Okay, and of course that comes with its own caveat, that is that the accuracy is not same at every level, at every order of magnitude. Okay, then we learned about some data types, strings, lists, right? And then we at the end we learnt about numpy arrays, which are very useful in doing computations, right? They are like matrices of any dimensions. And at the end, we talked about what is mutable versus what is immutable. Okay, so any questions from the last time? Okay, if not, then let's proceed. So these were some of the resources if you want to learn NumPy in detail. There are these 3 links. Okay, so let's start with this week's um, content. So the first one, how we started was using sequential statement, in which you go from one statement to the other, but you are never going to come back, right? There are no loops or anything. So this is a simple example. If I got is equal to 5, which means I got 5 rupees, and if you got 10 rupees, and if I want to calculate how much we have got in total, and I don't know how to add them up on pen and paper, I can write v got, which is another variable, is equal to I got plus you got, and then simply print we got, right? So the answer would be 15 in this case. So in this case, as you can see, we never went back. Okay, we never went up the steps. All right. And one thing to notice, if you are a beginner, you see I have used an underscore. I cannot use a space because the variable is always just one word. Okay. All right. Then we talked about if. So before we see this example, there is this joke that the programmer's mom said that please go to the market and buy 1 bottle of milk, and if they have eggs, bring 6. So this guy comes back with 6 bottles of milk, and mom asks, why did you buy 6 bottles of milk? And the programmer says because they had eggs, right? So if they had eggs, he brought six, but six what? So he bought 6 bottles of milk. Uh, okay, so the code structure is something like this. You have some variables. Let's say that we are talking about a match and India scores 3 goals and Germany scores 2 goals. By the way, we do have a semi-final match of India versus Germany in hockey today. Okay, so it would be awesome if the score is actually this. Anyways, doesn't matter. So we have two variables, goal India and goal Germany, and the task is to determine who won. So for that we can use if statement. So you start with if and then say if goal India is greater than goal Germany, then print India wins. So things to notice is that I is small. Yeah, do not use capital I. Then there is double dot or colon at the end, and then the whatever statement that you want to execute comes with an indent. So you press a tab or some number of spaces before writing this. Okay. Now, if you have just two conditions that either this or this, you can directly go to else. If you have multiple conditions, if this happens, then do this. If this happens, then do this. Then you use elif, right? So if goal India is greater than goal Germany, India wins, right? But otherwise, what happens? Maybe Germany wins or maybe they are tied, right? So we have multiple options. That's why we use elif, which is the short for else if. So if this is executed, the code doesn't see this or doesn't execute this. But if this is not true, then it goes to the second condition, which is that goal India is less than goal Germany. In that case, Germany wins. And then the final case, we don't need to give the conditions because if none of them is true, then it by default whatever remains that is the condition, right? So in this case the third condition is that goal India is equal to goal Germany, and in that case we print shootout, it's tied. Okay, so we will do in-depth examples of these kind of loops, but I just want to give a brief idea before we actually go to coding. Okay, so the next kind of loop is for loop. It is generally used when you have a list of things and then for each thing in the list you want to do something, and you write it like this. So first you write for, then in bracket thing in list, so this could be x in some set1 or something in some list, and then with everything you do something, and at the end you execute something or maybe print that thing, right? And often the list is range. So what range gives is a number from 0 to 5, or it could be from anything to anything. So what happens is that when we want to do something for some number of times, let's say I want to print something for 100 times, then I can just use range of 100. So this will run for 100 times. Sometimes what happens is that we really don't know how long it will take, how many times do we want to be in loop, but we know when we want to end, not in terms of number but in terms of some other condition. In that case we use while loop. So while, the structure is like this: while, then some condition, as long as this condition is true, uh, there is something that keeps on going, maybe it's printing every element, and whenever the condition first begins to not hold true, it will stop. Okay, so that was while loop. And then we learnt about functions, which are very useful in any type of language, so also in Python, and they are pretty much similar to what they are in math, how we learnt it in our 11th grade, right? What is a function? It's a kind of machine that takes in some input and gives it out some output. Okay, for example, a weighing machine. In that case, input is you or anybody, and the output is their weight, rather their mass, if we are being physicists. But you get the idea, right? So how do you define a function? It's pretty simple. First, you write the EF, which is kind of telling the code that I'm going to define a function. Then tell it the name of the function name, and the input that you want to give. This could be multiple inputs. Okay, could be x comma y comma z, etc. Then write your code whatever you want to do with the input, and then store the output in some variable output, and then return the output. Okay, we'll do the example so you will get a clear idea of what is being done. And one thing to note is that these two are optional, right? You don't really need to return output every time. Maybe you just want to print out something or do something to some variable. That's it. You don't want to return something. So this is optional. In the same way, input is also optional. Maybe you want to execute something, but it doesn't really depend on any input. Maybe you want to just print out some random statement. Okay. So both this input and return are optional, but more often than not, they are present. Okay. And then we learned about variables and their scope. So there are four layers in which they come. One is the local scope, which is when it is within the function. And then there is enclosing function, which is within the function, and the global scope, which is outside the function. So it's in only for the Python. Okay, for Python, if you write any x, it's going to be a global if it is outside the function. And there are some built-in variables which are just given by Python. That is something that we cannot do anything with. Okay, so those are the variables. And then we talked about recursive functions, which is when the function itself appears in the definition of the function. So there is kind of going in and in and in. If you have watched this movie by Nolan, I don't know if it was about dreams. So you go inside the dream and then go again inside the dream, etc. Right? So in that case, you define a function that is a function of some input n, and then give some base case, right? That if this is, then return the base value, whatever it is, right? Because we want it to end somewhere. But if it is not the base case, then give some mixture of n, which is the input, and functions of others n, which will be calculated again using this definition, and again, unless you encounter this base case. Right? So we'll do some examples of this. You can think about, if it is n is equal to 1, then it is 1, and otherwise it returns this value, n plus function of n minus 1. Then what will it give? It will give a triangular number. We'll do this example. Okay. And at the end, we slightly talked about algorithmic thinking, right? And that is all about being smart, not wasting time as in the processing time. For example, this linear search versus binary search. And the game is that I have a natural number from 1 to 100 in my mind. Okay, and you have to guess it. So how fast can you guess? And I mean, I should give a condition. Otherwise, you can. The best way is to just point a gun at me, and I'll just tell you the number. But the condition is that you can only ask me yes or no questions. So the naive way, which is the linear search, would be to ask me, is it 1? I say no. Is it 2? I say no. Is it 3? I say yes. Then it is 3. So, but that is very slow, right? Because I could have guessed 100 and it will take 100 turns. On average, it will take 50 turns, right? If I'm randomly picking a number. So this is order of n, or linear search. In other case, what you can do is binary search, in which you can ask whether it is less than 50 or greater than 50 or equal to 50. So is it less than or equal to 50? I say yes. So now the problem has reduced to half the size. Then you ask if it is less than or equal to 25. I say no. Then you know it's within 26 to 50. Right? So every time you are dividing the possible interval into half, and you carry on until you have just one number left in the possible range. Right? So maybe I'll explain this theoretically as well if I have time. Okay, so that was for the last week. If you don't have any questions, we'll do the assignments at the end of the session. We'll do some coding first. Any questions from this? Anyone? If not, then let's start coding. Okay, so the first thing that you do every time, almost always, is to write this sentence: import numpy as np. So I explained last time also, whenever you want to import a package or a library that comes with lot of functions, the numpy is probably the most important package in Python. So you import it as this import, then write the name of the package and give it some nickname. So everybody calls it np. So it's a standard practice to call it np. It's not mandatory, but it's always a good idea to stick to the convention, right? Because others will also see your code and you might see others code, etc. Okay, so the first thing that we write is this one, and it executes. Okay, now let's do some examples. First for if statement, and the example is that determining a grade. Determine grade, and the given conditions is that if it is greater than 90, give A. If it is from 70 to 90, B. Then 50 to 70, give it a C grade. And if it is 0 to 50, then give them F grade. Okay, so this is something that a clerk might want to do. And how do you code it? So we can use if else, right? So let's say that first we know the marks. Marks is equal to something. Let's say 56. Okay, and it all automatically gives me because now it has the AI. But let's say if we don't know, then we write the condition. First condition is that if marks is greater than 90, what do? We say that grade is equal to A, right? With a string. Alright. Now I cannot write else because then I have only two grades possible. So I should write L if, which is for else if. Else if marks is greater than 70. Marks greater than 70. What do? Grade is equal to B. Now can I use else for the third condition? Again no, because then I have another condition. So only for the last condition I can use else. Okay. So again I have to use if marks greater than 50 and grade is C. And the finally, if none of the first three is true, then I can use else, give the grade F, and then I am printing the grade. So what will be the answer? Answer is C, because 56 belongs to this group, right? Now, if you can notice, I'm not giving it 70 to 90 for grade B or 50 to 70 for C, even though that was what was asked in the question. And why is it? Because we know that this statement is executed only if this is not true, and this is executed only if this is not true. So we know that this statement only comes if marks is less than 90. So we don't need to worry about the upper bound. Okay. So I hope, yeah, either way you are coding with me, because that's the only way you are going to learn if you are beginner. Okay. So please have a laptop with you if it is possible. Otherwise, it's okay. Okay. So is the example clear to everyone? You can unmute and say yes. That's all right. Yes. Okay. See, you type in chat box, but I can't really see it. So it would be better if you can unmute and speak. Okay. I know it's always tempting to just write in chat box and don't not disturb the tutor, because I myself have been at that place. But please speak. Okay, then let's do one more example, which is determine if a number is positive or negative or zero. So we have some number which we can call x, which is 6. This stupid thing gives the answer. Anyways, we will type it out. So the first condition is, you can give anything. If x is greater than 0.
If we want to input the number, what we have to means if at all it is a new number, and just instead of
Yeah, then what? That's a good idea. We can write input x is equal to, and store it in x. So now it asks for input. Okay, and I can give 23. So now x is 23. If you want to see, I can print x, and it is 23. Okay, but as you can see, it comes with quotes, which means it's a string. So what I should rather do is convert it into integer. And let me give it 23 again. Press enter. Now if I run x, it will give me 23, the number. Okay. So yeah, thank you for the suggestion. In practice, I haven't seen many codes that ask for input, because you can always change the number here. Why do you want a window above there? But it's the same thing, and this looks more professional. Okay. So then it's very standard. If x is greater than 0, I want to print positive, right? Then note, by the way, notice these three things. I should be small. There should be double column, colon, which means double dots, and then the print statement should come with a tab. Okay, either single or double or many, as many as you want, but there should be some indent. Okay, and if I want to print another statement, it should have the same indent. Indeed. else print negative. Okay. So now what's wrong with this code? It's the double dot. Okay. So since x is greater than 0, it gives positive indeed. Let's now have a negative number -9, and then it should give negative. But what if I put 0? It will still give me negative. Why? Because we have just used else. What we should have used was elif. Elif, not here. So if you want to decrease the intent, you should press shift and tab. Okay, so you will go left. Elif x equals 0, then print 0. Now will this code run? I think there is something wrong. Can anyone point out? Let me run it and show it to you. Yeah. So assuming that none of you know, or maybe too shy to tell, whenever you have a condition with equality, you should use double equality. All right. So now it is a valid condition. We are asking whether x is actually equal to 0. We are not telling x to be 0. Okay. That's why we have double equality, just to separate it from the usual case when we are telling the computer that x is 0. Okay, so now it should run and it gives 0. All right. So yeah, you can play with this kind of codes. You can say I want to determine whether it's 0 or non-zero without using equality or inequalities. Then it becomes slightly interesting. Let's do it. Uh, Let me not write the problem statement first, because otherwise computer understands it and types it for me. So the problem is following. I am given an x, but I can't use equality or inequality sign, and I have to determine whether it's 0 or not. Okay, 0 or non-zero. So x is something 90, and I want to print whether it's 0 or not. So there is a fine trick, which is that I can just use x print. What do I want to print? Non-zero, else print 0. All right. So let's see. It gives this non-zero, and if I have 0, then it gives 0. So what is happening is that if you don't give anything, 0 is considered to be a false statement equivalent to, and non-zero is considered to be a true statement in this kind of if conditions. So this is something useful. Maybe in future codes it will be useful when we want to distinguish between 0 and non-zero. So you don't really need to write if x is not equal to 0. You can just write if x. So this is a valid code. Let me just type the instructions in case someone looks at it later. So the problem was to determine if a number is 0 or non-zero without comparing comparisons. Okay, just a fun quick example. Okay, what else can we do? Now let's go to for loop. and let's try to make an array which is the square of natural numbers up to some n. So let's say n is equal to 10, and now I want to print square of these numbers. So first let me make a set or list. Let me call it list 1, which will be set of natural numbers. So arrange, yeah, np.arrange. Then I want 1 to n, but as you can see the computer tells me to do n plus 1 because it is trained on millions of codes, so it knows that most people when they start with 1 they want to be n plus 1. Why? Because we want n to be included, so we want from 1 to 10. So arrange goes from 1 to n plus 1, so that when you print the list, let's just print it gives 1 to 10 because the n plus 1 is actually not computed. Okay, and if you do linspace then n plus 1 will actually come. So just remember this thing. So we have the list 1. What I want to do is square each number and print it. So for that I can use a code for loop, and we say for I in list 1 double dot, and I want to print I square. So how do you square it? Is type 2 stars. Okay, that means exponential. So I to the power 2 we are printing. Let's run it. Okay, what happened? So it should be capital L. So it prints out 1, 4, etc. Maybe we want to store it in list 2. So there are a couple of ways you can do it. One is you can say it's an empty array. There is nothing in it. And every time you append it. Dot append I square. Okay. And outside the loop you print list 2. So now it gives 1, 4, 9, 16, and this is a list. Okay. What will happen if I keep this inside the loop? Then for each entry it will print. So it will print 1, then 1, 4, 1, 4, 9. So now we can see how it is appending, right? So this was using 4. Why? Because we wanted to do something with every entry in list 1. Now, by the way, there is a nice little trick using which you can print in just one line. Okay, I can say list 3 is equal to I square. But what is I? For I in list 1, and then just print list 3. Alright. So this is a nice way to define arrays from arrays or lists from lists. Just tell it what to do with every element and then just write for I in list. Okay, same thing. This is cute. Okay, anything else we can do with for loop? Yeah, maybe let's do this one. Which is get Fibonacci numbers. Now, do you know what Fibonacci numbers are? Can anyone unmute themselves and speak? Anyone, just Fibonacci numbers. Why are people leaving? I won't pick up random people and ask them. Don't worry. Okay, if they are unwilling, then Let me tell it myself.
Actually, my
Yeah.
for me also this problem is coming like two sessions are overlapping for other subject and this subject. So
Oh,
if we are attending this, we cannot attend the other one.
oh really? Which course is that?
This is research methodology.
Ah, okay. Oh,
So that every time it is coming on Monday, Tuesday, same time 6 to 8.
ah, I see. I mean, I don't know if anything can be done with it because there are simply so many people and so many courses being run
Yeah.
at the same time. But yeah, you can pick one, and I'm sure they are also uploading the YouTube lectures.
After that, we
Yeah,
have to see that. Correct.
and I am also doing that, so it's your choice. Okay, okay. So where were we? Yeah, Fibonacci numbers. So Fibonacci numbers start with 1 and 1. So it's a sequence of numbers. And then you add last two elements. So it becomes 1 plus 1, which is 2, then 2 plus 1, which is 3, then 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, and so on and so forth. Okay, so these are the Fibonacci numbers. And we want to print this maybe up to 100th element or something. So let's call that variable 100. And sorry. And now what I want to do is say um, x1 is equal to 1 and x2 is equal to 1, and it automatically gives me list for how smart and stupid it is. Okay, and then what I want to do is for I in range no, and okay, I want to print first. I want to print something, or should I append it? Okay, let's just append it. So I define a new number which is going to be appended, which is x1 plus x2, right? And then in list 4 I append x3, and let's just comment this for a moment. So this is how you comment, by the way. Just use hashtag, and commenting something means that the code will not see it. It's just for your eyes, but the program will not execute it. Okay. So what will happen if I run this? Let's say up to 10. So the list is 1 1, then x3 will be 2, right? But x1 and x2 are still 1. So again x3 will be 2. So it will just give me 2 2 2 2. So now I have to update the new numbers. So x1 becomes x2, right? The first number becomes the second number, and second order number becomes the third new number. Okay. So this way now in the next session, next iteration, x3 will be summation of these two numbers, these new numbers, which is what we wanted. So now if we run it, it gives us this sequence, and we can go up to, let's go up to 50. Yeah, so it gives us this entire sequence, and very fast. We can do one thing. Let's calculate the ratio of consecutive numbers, and let's see what happens. So for j in range and I want to print ratio of 2 divided by 1, then 3 by 2, 5 by 3, etc. Okay, so I want to print list 4 of j plus 1, which is the right side, divided by list of j. Okay, so what do you think will happen? Oh, did I do some? Oh, this should be list 4, right? Silly me. So it gives 1 to 1.5, and then it quickly converges to some number. And if you learnt about this, this is the actually golden ratio. So, and we can now see how quickly it converges, you know, how the error decays with n, etc. So maybe when we learn plotting, we'll do this. Okay. So this should be ideally 1 plus square root of 5 by divided by 2. Square root of 5. This entire thing.
Last number shows the same this thing, same value.
Yes.
Of,
So, but the following digits may not be same. You see.
okay.
So
Yeah,
up
yeah,
to
yeah.
this many digits is the same. Whatever. Oh, I should use NP. Yeah. So you see, it's the same thing, and you can basically solve the equation x square is equal to x plus 1, and this is a positive solution for that. Anyways, doesn't matter. The point that I'm trying to convey is that using this simple for loops, etc., you can already start to do these little things, some intriguing things. Okay, now let's look at something else. Okay, so we did if loop, if conditions, and for loop. Now let's look at while loop. For that, what I want to do is calculate sign of some number using Taylor series. So in case you don't remember it, the Taylor series for sine is start with sine of x is x. Yeah, for us physicists, this is pretty much that we need as long as we are doing linear dynamics. But the next term is x cube over 3 factorial, then plus x to the power 5 by 5 factorial, right, and so on and so forth. Let me write one more term, actually x to the power 7. So just the odd terms divided by 7 factorial. And we want to do this using while loop. Why? Not because that's the best way to do it, but because we want to learn while loop, and this serves as some kind of pedagogical example. Well, so let's say x is some number 0.5, and we want the series up to 10, 11 terms, right, up to x to the power 11. So what we can do is while I is less than n, right, less than or equal to n, we want to do something. So we should start I from somewhere, and we know that first term is x to the power 1. So so we are treating this exponent as I. Okay. So I is 1, and we store the value of sin x in y. So y is first term is just x. In fact, we will add first term in the loop itself, so it is 0 in the beginning. And what we want to do is just add in y. So y is equal to y plus x, right? So x. This is only for the one, first term. For the other term, I actually need the exponent I. So I use I. But I also need divide by factorial of I. So I do np dot factorial I. So np dot math dot factorial. This is one way to give the factorial. Okay. And then we say I is equal to I plus 2 because it is jumping by 2, right? Then we have x to the power 1, then x to the power 3, then x to the power 5, right? So I'm every time I'm adding x to the power I divided by I factorial. And now I'm making some mistake, I know, and you should be careful. and try to think what is the mistake. So let me print y, let me print sine of x, and let's see how close they are. What happened? Oh, np dot sine. I always forget. Yeah, pretty close, but again, not so close, right? So maybe we are truncating it to small number of cases, small number of terms. So let's make it 50, 51. Yeah, still some error. So what is the error? Anyone? What is wrong with this
So sign, signature, plus or
signature?
minus.
Right. So what is happening is, yeah, what's happening is that we are always adding it, right? But we have minus, then plus, then minus, etc. So what we should do is put some sign SGN and multiply it, whereas sign is some plus or minus 1. Okay, so we start with positive, right? Because the first term is plus, so sign is first is 1, and then when we add 2 to the I, we also invert sign. Okay, so sign becomes minus sign. By the way, we can use this notation also, which is same as this. I plus equals 2. Okay, in fact, let's do that one. So you may see this in some code. What it means is that add to I 2. So I becomes I plus 2. This is the shortened notation for this. Okay, now let's run this. Yeah, you see, almost the same number. In fact, we can print the difference also. Print y minus np dot sine of x, and it gives 0.0 because up to this many digits, maybe 16 or something. It's same. Okay, and maybe if we have bigger x, then we'll have some error. Yeah, now there is some error, but that is in order of 10 to the power minus 14. So up to about 14 digits, it's same. It's giving the correct answer because we have 51 terms. So now we can start playing around. Okay, we just have 5 terms, but x is say 1, which is about 60 degrees. And then we have error of about 0.0002. So 10 to the power minus 4, something like that. Okay. So, and once you know how to plot this, you can plot the two series and see where it starts to deviate for a given number of terms, for given values of x, etc. Right? So, fun stuff. Anything else? Now let's look at some functions. So, uh, first that I want to talk about is the triangular numbers. It is pretty much similar to factorial except that we add instead of multiply. Okay, so let me just quickly tell what triangular numbers are. So triangular number of n is basically 1 plus 2 plus 3 all the way up to n. And why are they called triangular number? Because you can think of them being stacked like this: 1 plus 2, then 3, right? So they are building some kind of triangle, and we know that formula for this is n into n plus 1 divided by 2. I hope you can see the screen. I'm scribbling something. Okay, and this is a this is a nice geometric proof kind of, because if you repeat the same thing, you add 1 here, 2 here, 3 here, and 4 here, then it just becomes 4 into 5. So in general, n into n plus 1, right? But you have two copies of this same thing. So one thing is n into n plus 1 divided by 2. Okay, and we can define triangular number of n recursively as well, right? It is just n plus, so we have n, and then 1 plus 2 plus 3 all the way up to n minus 1, which is the triangular number of n minus 1. Okay, so we have two kinds of definitions for this. In fact, three if you consider this as well. So let's try to do this, all three of them. So first one is, so we want to learn how functions are defined. So let's define first triangular number of n in this way. It gives me everything for I in range n. Now I start with y is equal to 0 and add y is equal to y plus I, right? So it will first add 0, then 1, then 2, etc. And then I return y. Okay. Oh, by the way, because I want to start from 1, I should write 1 to n plus 1. Okay, or I could have written y plus I plus 1. Okay, so let's run this. And then it's a try 1 of 5. So it gives me 15, which is correct. 5 plus 4 is 9, plus 3 is 12, plus 2 plus 1 is 15. Okay, so this is the first definition. Now, which used, by the way, for loop. Okay, now the second definition, which is just formula, right? So I can directly return n into n plus 1 by 2. Okay, so that's another way to do it. And the third definition, which is using recursion. So can someone tell me how to do it? So what would be the base case? Base case would be just 1, right? If I have just one number and the sum is 1 plus 2 plus up to 1, which is just 1. So it returns 1. Otherwise, what do we do else? Return n plus triangular number of n minus 1. Okay, which is this third definition, this one. Okay, so now let's run this. Okay, what mistake did I make? It's the same thing, right? I was telling you about double call. Now just to check, let's print the triangular numbers. So wow, it's like it's reading my mind. No? So for I in range 1 to 10, I want to print triangular number using first, second, and third. And if everything goes well, they should be same, right? So 1, 1, 1, 3, 3, 6, 6, 6. Now, as you can see, the middle one gives 1.0, 15.0, and the triangular 1 and triangular 3 gives just integers. You can think about why that is the case. Can someone tell me?
It's becoming float in the division thing.
Yeah, so we are dividing it by 2, okay, multiplying, so that is making it non-integer. Right. What else can we do? Uh, Same way we can do Fibonacci numbers, right? So we did that earlier, in case you forgot. These are the Fibonacci numbers 1, 1, 2, 3, 5. So add previous two numbers. So which is what recursion wants, right? So I can define Fibo and Fibonacci. Let me name it here. Maybe it won't give that. Oh, even then it gives. So base case is if n is equal to 1 or n is equal to 2, you return 1, right? So you can write it separately or is a conjunction operator. Okay. So this statement will be true if any of this is true. Okay. So if n is 1, then also this will be executed. If n is 2, then also it will be executed. Otherwise, the recursion definition is written Fibonacci of n minus 1 plus Fibonacci of n minus 2. So adding last two numbers. So if we give this function n is equal to 10, then first it will check whether it is if 10 is equal to 1 or 2. Of course it's not. So it will return Fibonacci of 9 plus Fibonacci of 8. Now for calculating 9, it will again do this, etc, etc. Okay. So this is how we can define Fibonacci sequence. And let's print for I in range which knows everything. So 1, 1, 2, 3, 5, 8. Okay. Up to the ninth element because range is from 1 to 10. Okay. And something else. Yeah, we can do Hanoi also using recursion. So Tower of Hanoi, if you have seen the lecture videos, professor explains how it works in case you haven't seen. And nonetheless, it's interesting to see how it works. So this is one website which I found, which lets you play the Tower of Hanoi. And you can change the number of disks also. And the goal is simple. You want to transfer this set of disks to another tower, third tower. You are given 3 towers. You want to do it in minimum number of moves. So the first thing you would want to do is pick up everything and just place it here. But that is not allowed because you can only move one disk at a time. That to the top one. Okay. So you can put this one on this, and then I can put this one on this, except that I cannot because this is bigger than the one which is under it. Okay. So I can only place the smaller disk above the larger disk. You cannot place a larger disk onto a smaller disk. So if I put this, then my only option is to put this one to this one, and then this to this. That's it, right? So how do you solve it? You solve it if you have n disk. Then first transfer this n minus 1 disk to this tower using some algorithm, which we don't know, which is the same algorithm that I am describing. So it is recursive. But once you have transferred this n minus 1 disk here, put the largest disk to the third tower, which is where you want it to be, and then now do the same thing with this tower and put the entire set here. Okay, so if you look at it, how many moves does it require? So you have 3 towers and you have in total n disk. So first you want to move n minus 1 disk here, right? And let's say fn is the number of turns it will take. Then for transferring n minus 1 disk here, it will take f of n minus 1. Then the bottommost disk, which is the largest disk, will be transferred here, which will take 1 turn. And then again you pick up this n minus 1 disk and use this f of n minus 1 turns to transfer this set to this disk. Okay, so all in all you get f of n is equal to 2 times f of n minus 1 plus 1. So this is the equation and we know the solution, right? The solution is 2 to the power n minus 1. How do you prove it? Using induction. Okay, so we can easily prove using induction. Shall we do it? Yeah, we have some time. Let's do it. So for one base case, it is 2 to the power 1 minus 1, which is 1, which we know is true, right? We want to shift one disk, it takes 1 turn. And if it is true for n, let's say it is true for n, and for n plus 1, it becomes 2 to the power n plus 1. So now 2 times 2 to the power n and minus 1. This is basically your fn and plus 1. And this will become 2 to the power n plus 1 minus 2 plus 1, which is minus 1. So this is actually f of n plus 1. Okay, so what we learned in 12th grade comes in handy here. You can prove it, but you can also calculate it using this equation, right? Using Python recursion. So let's do it for 3. Let's play it. So I want to shift these 3 to here. So I shift these 2 to here, which means I shift this one to the third one. And now I shift this one to the second. Put the third to the second and the largest disk to the third tower. And now I want again to shift this entire thing to here. So I first put the smallest disk here, then this one here, now this one to the top, and it takes 7 moves, which is 2 to the power 3 minus 1, 8 minus 1. Okay, so this you can play. Okay, where were we? Yeah, so we want to do it using functions. So let's define a function. Let's call it Noi. It's also called Tower of Brahma, I think. I'm not very sure. So it's a function of n. And first base case, if n is equal to 1, again, since I have if, I want to compare n with 1, right? So double equality. If n is equal to 1, then we should return 1. Right? Same as induction. Else, return 2 times f of n minus 1. So 2 times Hanoi of n minus 1 plus. Okay. Now let's look at Hanoi of 3 and the answer should be 7. Okay, so 2 to the power 3 minus 1. If it is 10, then we know 2 to the power 10 is 1024. So -1 is 1023. Okay, so that's, I think, what was covered in week number 2. So any questions in any of these codes? I'll share this notebook in the drive folder. Any questions? If not, then we'll go to solving assignments. Have to move on. Okay, sure, no problem. So let's solve assignment problems. I see many people have classes from 7. So let's quickly solve the problems. Most of them are pretty much easy, so should be okay. So first one is, what is the purpose of else statement in if elif ladder? If condition 1, then do this. Elif condition 2, do this. Else you do this. And the options are, else statement will execute if none of the conditions is true. Else statement will execute if all the conditions are true. And it will execute if the condition just above else statement is true. So what is the correct option? When will else execute? Only if none of these are true, right? If some of them are true, then the first one will be executed and the others will not be executed. Yeah, 1. Nice. Thanks, Aparna. Okay. Second one. Write the output of the following. X is equal to 10. If x is greater than 7 and x is less than or equal to 10, print, notice the indent, okay? Print pass and then comma and with double quotation, and then print fail. What will be the output? Type in the chat box. Okay, let's see. X is 10. So let's see if this condition is true. X is greater than 7? Yes. X is less than or equal to 10? Yes. Okay, so it will print pass and then it will print fail. So it is either C or D, third or fourth. So Ankita says pass. Okay. But you see that after pass, it gives fail also. So why
It's a
only
third
pass?
one.
It's the third one. Okay. Any other guesses?
Last one.
Last one. Okay, yeah. If it is not third one, then it is last one. First of all, it cannot be first or second, right? Because if pass is printed, fail is also printed. The thing is, there will be a new line or no. And turns out that because we are not ending it with anything, we are not ending with new line also, right? That's why it will just merge both of them and it will print pass fail. If you don't believe me, you can just type this code in your Python and just see. Okay. And it's okay if you didn't know. I myself didn't know before this one. So, and the idea is because you are ending it with nothing. Okay. So the result is pass fail, which is like the result of Schrodinger's cat exam. Okay. So was I clear? Any doubts?
Is it backslash? Then it will go to the next line. It was
No.
like that.
If you don't do anything, if you just write print pass and print fail in new line, then it will give new line. Okay.
Okay.
Let's do it actually. Let's just print hi and then print yo. So it gives hi and then in new line yo. Okay. But if I give and is equal to, it gives hi yo. Now if I want to do ulta of this, same line, and if I type yo here, then what happens is hi and yo are printed together with a space, which you can change. You can use some delimiter or something. Okay. But if I want to give it a new line, then I can just say backslash n and then print yo. Then it gives a new line. Okay. So that's that. Maybe I can merge these two as well. I'm not very sure. Yeah. So this backslash n works as a new line and then yo is printed. Earlier what was happening is that just like between hi and yo there was a space. There was a space between backslash n and yo. Okay, so that's why yo was printed after a space. You see? Okay. Now let's look at the next example. Next question. Again if else. If 3 plus 8 divided by 2, and this symbol is for not equal to. So just like we write on paper equals to with a slash, right? But we cannot put slash on it. So we write exclamation mark then equal to, which means not equal to 7. Print h else print b. What will be the answer? Anyone? Type it in the chat box. B. Ankita says it's B. Oh, Tanuja wrote password. Yeah, right.
Actually,
Yeah.
some of the questions are repeated yesterday also the,
Not
in the
some
session.
in the Sundays session you are saying?
Sundays, yeah,
Yeah. So that will be repeated. I'm sorry, but
repeated.
that
Okay,
is
okay.
what
No,
we
no
have been
problem.
asked. Okay.
No, no, it is a practice for us. No?
Yeah. I see. So if you have already done that, then we cannot offer a new questions. Okay, because both sessions are supposed to discuss the same thing so that people can join in either meeting and still don't miss out anything. Okay.
Okay.
Yeah. Okay. So the answer is B, right? B. And why is that? Because if you do 3 plus 8, which is 11, and divide by 2, it would be wrong, right? Because the preference is given to division sign. So first you do 8 divided by 2, which is 4, plus 3, which is actually 7. So this statement is not true. 7 is not equal to 7 is incorrect statement. So it will go to else condition, which tells it to print B. So it prints B. Okay. Now the next question. Very chindi. A graphical representation that shows step-by-step solution to solve a given problem is. So you have algorithm, flow chart, line chart, and pie chart. So what is it called? Chat box. Flow chart 2. Right. Okay. So algorithm is the flow chart, but it's more abstract thing, right? And when you want to graphically represent it, what is doing? You do flow chart, and probably in school you already learned, but I didn't. My teacher, for some reason, uh, didn't decide to teach me that. So I learned very recently that you have different shapes, diamonds and circles, and everything means something. But that's a very nice way to just clarify in your head what is happening and just show every step. Okay. Most people don't really do that. Even I myself never draw flowcharts, but some people actually do that. So I'm in IIT Bombay. I was staying for a course, and there was this guy who was all India rank 2, and he's in computer science department GE, and he always prepares flowcharts before writing a code. So maybe that's a very good practice. Okay. So anyways, algorithm is a abstract thing, and flowchart is what you draw on the paper, and line chart and pie chart are sort of graphs. We will draw a line chart throughout this course. Okay. Now the fifth one. Okay. Slightly convoluted, but still easy. And it's like this. Write the output of the following. A is this 155, B, C, D are 126, 237, 388. And what's the output? So can anyone print the output? B, B. Okay, 2. Let's look at it. So first, if A is greater than B, right? So is A greater than B? Yes, 155 is greater than 126, so we go inside. If A were not greater than B, then there is nothing in that indent, right? Corresponding to this if, there is nothing, so there won't be anything. But because A is greater than B, we go inside. Now if C is greater than A, yes, 237 is greater than 155. Again we go inside. If this was not true, then we would have jumped to this one and printed A, right? But that is not the case. So if now we have to see this one, if D is greater than C, D is greater than C, sorry, D is less than C, which is incorrect. So it won't print hello, but else it prints B. So it will print B because D is actually greater than C. Okay, so B is the correct answer, right? Next one, what can be defined as a named group of instructions that can accomplish a specific task when it is invoked or called? Okay, so we have all learned about this. It's called a function, right? And this is the terminology that you use. You call a function, right? You are doing something, you are writing your code, and suddenly you want to, you require Fibonacci number of 5. So you call this function Fibo function. Hey, Fibo bhaiya, please give me the Fibonacci number of 5. And then it operates on this set of instructions and finally gives the output. So function of function is to execute that function. Okay. I don't know why that is in assignments, but alright. Seventh one. Which of the following statement is outside of the function sum? So this is the definition of sum. A is integer of input enter number, right? So if we give some input A, same with B, then S is equal to A plus B. So it will add these two numbers and then print S. And is it actually true what I said? That would happen if everything was inside the definition. But the question is, which of the following statement is outside of the function? So what would be the correct answer? Fourth option, Tanuja. Yes, Aparna, 4. Correct. 4 is statement, both statement 3 and 4. Right? It's all about indents because it does not have intent. It's not inside the definition of function. Okay. Write the output of the following to define a function called cal, which takes in two inputs, m and n. If m is equal to n, then return m times 3, otherwise return m times 2. And s is cal of 9, 8, and then print s. So what would be the value of s? 18. Right, Tanuja. Yeah. Why? Because it asks if m is equal to n. So if 9 is equal to 8, then this will be executed. But we all know, right? It's a fundamental theorem of maths that 9 is not equal to 8. So we go to the other condition, else condition, which is written m times 2. What is m? The first number. So this will return the first number times 2, which is 9 times 2. Okay, so 9 times 2 is, I think, 80. So right. Now this one, choose the correct statement. We can create function with no argument and no return value. We can create function with no argument and with return values. And we can create function with arguments but no return value. What can we do? 1. We can create function with no argument and no return value. That is true. But we can also create function with no argument and return values. That is also allowed. And we can create function with arguments and do not return any value. That is also allowed, right? So answer should be 4. Right. So let's see. If you don't believe me, let's define
No,
a
no, you're
function.
right. You're right.
I'm right. Still, maybe someone has doubt. Maybe someone is watching on YouTube. So let's define a function. It is a function of n, and it just print. Okay, prints n. It's not a very fancy function, but it is a function, right? And if I call function of 4, then it prints 4, right? So it's not returning anything, it's just printing 4. Let's say if it is returning something, I can say y is equal to function of 4 and then print y. So what should be the answer? Tricky. It's none. So because we executed this function of 4, it printed 4, but it was not stored in y because this function didn't return in the serve. Okay, so y still is nothing. So y has this none type. Okay, we can do one more thing. We have no argument and we are printing something. So namaste. We just want to print namaste. Alright. So now what will happen? I can just call function and it will print namaste. Again, it's not returning anything. If we want to return something, we can return it also. Return namaste. And now if I write fun, it actually prints namaste, but it actually stores it as well. So I can write y is equal to fun and then print y. Oh, still it's not written. Okay, this is something new for me. Yeah, I didn't run this after editing. So it is printing right? And because it is returning, so namaste is stored in this y, and then when we print it, it gives namaste. Okay, so the correct answer is all of the above. We can do all combinations: no argument, no return, no argument with return, with argument, no return. Okay, and of course argument and return, which is what we generally do. And a function may return multiple values using list, tuple, string, or dictionary. Tuple, Tanuja says tuple. Okay, let's work it out. Let this function return 2 and 3. Okay, and now I call that function and print it. So it prints 2 and 3. So this is a list, right? Except that it's not. Whenever we print the list, we have seen it. It's in square brackets, and this gives in round brackets, right? And that is called a tuple. More or less they are same thing, except that we have learned about mutable and immutable objects, right? So these tuples are immutable in comparison with the list, which are mutable. And professor gave very nice reason why they are mutable, because we don't want to store, every time we are doing something, we don't want to make another copy, etc. But whenever function returns something, it gives in tuple, which are mutable. So the correct answer is tuple, as Tanuja rightly pointed out. Alright, so that's about it. Any questions in the assignments or anything?
You will send the link for this lecture, no?
Yes. So this is the YouTube channel, and the link will be shared on your NPTEL as well. So if you go to your NPTEL, not this one, yeah, this one, looks like this, right? And then you go to this problem solving session and go to this recordings. It gives this link to a Google Sheet where you can access both the my presentations as well as Agrim's presentation. So this second column is for mine, and here you will find the week 2 recording, and this is the drive that has the codes and slides. Okay.
Thank you.
Yeah. Anyone else? Any questions? Comments? Okay, if not, then let's call it a day. Thank you very much. We'll meet again next week.